The previous chapters focused more so on Six Sigma, and this chapter overviews Lean. If you're taking the formal class, we've seen Lean previously. So while some of this chapter may echo that previous material, repetition strengthens learning and helps build mastery. Lean centers on reducing waste. It's also called the Toyota Production System, the TPS, since it was primarily pioneered at Toyota. Yes, that's the Japanese car company. In general, lean is attributed to the Japanese, though the term lean was coined by Americans. That is, the Japanese don't call it lean. The text emphasizes how lean and Six Sigma work well together. Still, lean is novel and compelling to U.S. organizations since it contradicts many traditional Western production and quality ideas. We can think of lean as a set of tools as well as a mindset to improve quality, timeliness, and flexibility. Ideally, every process step adds value with minimal, if any, waste. And you can employ one or a few lean tools to reduce waste and improve value. First, lean seeks small, quick changes which accumulate over time to offer big impacts. And then second, lean focuses on improving flow of materials, people, and information, as well as reducing resources like labor, equipment, and cash. The hidden factory represents waste as resources are consumed without producing value. And this hidden factory manifests as workarounds, scrap, and rework, meaning fixes. We all face it every day, but the organization generally isn't able to see it or measure it. That's why it's hidden. And then third, lean focuses on creative problem solving from people. While process improvement and quality always involve people, lean places an extremely heavy emphasis on total involvement. The idea is to challenge all employees to identify waste, as well as help devise fixes to eliminate that waste. Let's return to the relationship between Lean and Six Sigma. Both are powerful for improving processes and quality. However, they have different approaches to do so. For instance, Lean looks to reduce waste, while Six Sigma looks to reduce variation, including defects. So similar yet slightly different areas of focus. And then lean seeks small, fast improvements that add up over time to create big changes, while Six Sigma involves slow, big improvements over, say, 6 to 24 months. And then with lean, ideas primarily come from people, and with Six Sigma, the ideas primarily come from the data. Still, Lean and Six Sigma are not mutually exclusive. They can be used together. Your certifications will be Lean Six Sigma. And the text maintains that Lean goes hand in hand with Six Sigma, quoting, "Most Six Sigma approaches today incorporate Lean." Again, Six Sigma emphasizes defects, which are failures to meet customer requirements, while Lean looks for waste, which reflects unnecessary time, labor, or materials. That is what's not required for the process to create value for customers, meaning a satisfactory outcome. So we can likely eliminate the waste to improve value. And at a minimum, removing the waste will probably decrease costs. Again and again, waste is the driving concept of Lean, also called the Toyota Production System, TPS. And the Japanese term for waste is muda. The goal of Lean is to identify and minimize muda so that every step of a process adds value. Many practitioners apply the Tim Woods acronym to remember sources of waste. So that stands for transport, inventory, motion, waiting, overproduction, overprocessing, defects, and finally, skills. The text presents 7 muda, which generally mirror Tim Woods. And these include overproduction, correction, meaning defects, inventory, motion, conveyance, meaning transport, overprocessing, and waiting. And then the text also offers 3 additional sources of waste, including talent, ideas, and capital and cash. So number 1, overproduction is one of the O's in Tim Woods, and it means that we make too many items. In other words, production outpaces demand. And this can occur because we produce too fast, at the wrong time, or too much. And realize that overproduction is closely related to inventory waste. That is, inventory is the manifestation of overproduction. Overproduction and inventory can relate to finished products, as well as work in process, that is, inventory still in production. So when production steps don't run in sync, one step runs faster than another, creating overproduction inventory. Specifically, the bottleneck is the slowest step in the process that ultimately limits production, and inventory will build around that bottleneck. And then preparing equipment that isn't used can also be considered overproduction. And overproduction can involve virtual production, such as reporting and digital assets. For instance, the text highlights a report that no one reads as overproduction. Number 2 is correction, meaning defects, which is the D in Tim Woods. So correction represents defects during production that need to be fixed before the customer experiences them. And the industry term for correction is typically rework. It's reworked. And rework is waste since it increases time as well as consumes additional labor and materials, representing that hidden factory, spent resources that don't create value. Rework can occur with both products and services. And we've all experienced call centers and help desks that loop us back through to correct defects created by poorly designed processes or employees that are not committed to customers. Number 3 is inventory, the I in Tim Woods. An inventory represents materials that are waiting, which can include raw materials, which have yet to enter the production process, or work in process, WIP, is in production but not yet complete, and then finished goods have completed production, meaning they're finished. Batch processes, which mean making many of the same items at once to improve economies of scale, create inventory at the bottleneck, the slowest step of the process. However, lean seeks small batch sizes, ideally one-piece flow, meaning a batch size of 1 item. An inventory is also created when items are purchased or produced before they're needed. So that relates back to overproduction. Number 4 is motion, the M in Tim Woods. And this represents employee movement. That is, excess motion, often due to poor layout, represents waste. And then we can also see excess virtual motion, such as switching between screens on your computer. This also represents motion waste. And one helpful tool to assess unnecessary motion is a spaghetti diagram, where we simply trace movement to visualize problems with layout, such as excessive motion, seen as long, winding, or looping lines, backtracking, lines that repeatedly return to the same location, and congestion and intersection points, lines that overlap. Number 5 is conveyance, which is represented by transport, the T in Tim Woods. Conveyance involves the movement of products, inventory, or resources, so it's similar to motion. And conveyance can also apply to virtual materials such as data, workflow, and email strings. And once again, the spaghetti diagram, which we just saw for motion, can also help track conveyance waste. Number 6 is overprocessing, the other O in Tim Woods. And this means the finished product or service has more value than the customer wants. And I think this is the hardest one to understand. Again, it's excess value not wanted by the customer. As one example, think of all the buttons and features in cars that most people don't use. So if the organization doesn't understand customer expectations, the voice of the customer, they can overprocess the outputs. Or perhaps a desire for perfection or even employee excitement can also create overprocessing waste. And the text emphasizes a value stream map to help identify overprocessing. And again, with lean, every step of a process adds just the right amount of value. And number 7 is waiting, the W in Tim Woods. This reflects idle time of machinery or people in a process. For instance, a process, or maybe a step in a process, operating below capacity, or perhaps not operating at all, represents waiting. Changeovers, meaning setups between production batches, also cause waiting. So lean aims for very fast changeovers. Additionally, steps in a process that don't operate in sync, such as due to poor flow, create waiting at slower steps. Again, this goes back to the idea of the bottleneck. A process can only run as fast as the slowest step, that bottleneck. So balancing processing steps, meaning syncing cycle times, as well as proper scheduling can reduce waiting waste. And the theory of constraints, the TOC, is one popular approach to identify bottlenecks to improve flow and cycle times, though we won't cover it here. The text offers 3 other forms of waste, with number 1 being talent, which is similar to S, skills, in Tim Woods. Talent can be wasted when the organization or a process does not make the most of labor skills. For example, talent waste can occur from hiring the wrong people, poor staffing, or ignoring an individual's potential. And that last point is similar to number 2, ideas that are discounted or not sought out in the first place. This also represents waste. In such environments, people stop coming forward with ideas. So the text highlights brainstorming as one effective tool to help employees express and develop ideas in a safe environment. And then number 3 is capital and cash, which can be wasted when leadership does not invest in improvements that can return on that investment via reduced waste and or improved value. The text presents 2 types of muda, type 1 and type 2. Type 1 muda involves non-value added tasks that are still required, so we can't get rid of them. For instance, inspection for quality is considered waste. But until we implement prevention, meaning zero defects, we still need to inspect for quality. And the text presents an example of HR, human resources, as type 1 muda, since it doesn't directly impact the end customer. Not sure how I feel about that one. And then type 2 muda is not essential and can be immediately eliminated without any impact on the process or quality. So that's low-hanging fruit to get rid of immediately. We now switch gears to tools to find and address waste. And one tool is 5S, which represents a clean, organized workspace. So 5S loosely translates from Japanese as sort, straighten, shine, standardize, and sustain. But we can simply generalize 5S as a clean, easy to understand, meaning intuitive, visual workspace. Everything is easy to find and put back. And even someone who's not familiar with the workspace can quickly come up to speed. So a few 5S examples include a shadow board that makes tools easy to find. It can show where each tool belongs, as well as when each tool is missing. Or a color-coded work table with labels can organize clutter. And signage around facilities makes locations easy to use. And then carts, bins, and even trash cans have their specific labeled spot on a clean floor. 5S is executed as a series of steps that can overlap, starting with sort, where we review all items and materials to see if they're needed, keeping only what's needed for the work. That is, we identify unused or wasted resources, which will also free up space. And this sorting can apply to virtual processes too, such as computer files, cleaning up your computer files. And then number 2, straighten or set in order, meaning we create a place, a home for every item, tool, or material. The idea is a place for everything and everything in its place. That is, everything is easy to understand and find. We also label everything that may not be recognizable to most employees. Again, ideally, anyone can quickly understand the workplace, which can certainly be applied to digital environments such as systems and your computer. Number 3 is shine or sweep, sanitize, or scrub, meaning that we thoroughly clean the work area, including returning items to their proper place. And this cleaning can include inspection to spot issues early. And again, this can all be applied to both physical and digital environments. Then number 4 is standardize. We maintain progress in the 3 previous steps. That is, we create consistent procedures and visual controls to maintain the first 3 S's. And number 5 is a similar idea with sustain. We make 5S a habit and a core part of the daily routine. Everyone works together and follows the rules to ensure adherence and improvements. So these last 2 S's help control processes. The chapter closes with just in time, JIT. it's another tool to identify and eliminate waste in lean. With just-in-time, outputs are produced as needed, meaning as demanded by the customer. And this is in contrast to traditional US Western production, where finished goods are produced well ahead of demand. So all that inventory in physical stores like Walmart and Home Depot, and even online stores such as Amazon, is produced well ahead of demand. So it's not just in time. And the text emphasizes that the customer can mean the end customer of the organization, though for most employees, the customer is internal to the organization. So just in time can apply to internal processes, including your own work. So on the surface, just in time seems more like a simple inventory management approach. However, it has close ties to quality and process improvement. So recall that inventory is a source of waste. Specifically, it can hide problems. For example, we hold excess inventory just in case our suppliers deliver late or in the wrong quantities, or perhaps they deliver defective materials, or maybe we create our own defects in production. So we hold inventory to cover up that waste. If we reduce the inventory, we're forced to eliminate these wasteful just-in-case issues. That is, just-in-time forces us to identify and eliminate waste in processes. So it's about process improvement as much as it is about reducing inventory. And the book emphasizes that just-in-time is not always fully possible. Still, we can at least try to come as close to producing when the customer needs it. And moreover, the text notes how just-in-time also represents a more general concept of lean, focused on eliminating waste.